Hi everyone, my name is Natalie Ko, and I'm a product engineer with Misumi USA's Electrical and Tooling division, and today we'll be talking about these things, circuit breakers. They're a very common component found in a lot of control enclosures, but there's a lot of information surrounding them, and it can be difficult to try to find the right one for your application. So today I'll be going over a lot of the terminology that is used to define circuit breakers. I'll be going over the different types, as well as the certifications that surround them. And we'll be discussing the applications that they have so that we can try to find the right one for you. There are three very important terms to consider when looking for a circuit breaker. You have the rated current, the trip current, and the ampere frame. The first one, rated current, is the current that the breaker is supposed to operate in what's called normal or nominal conditions. These conditions are set by the manufacturer and can be found in their spec sheet, but they usually relate to the maximum operational time and temperature for the breakers. The second one is the trip current, and that's the point at which the breaker goes from the on position to a tripped state, where it is broken, the internal connection is no longer allowing power to flow downstream. It's important to note that rated current and trip current, very different things. It is possible for breakers to experience an inrush current that is higher than the rated current, but not enough to actually trip the breaker. It is only when that inrush current meets or exceeds the trip current that the breaker will shut off. The final term, ampere frame, is used in relation with the trip current to define the overall breaking capacity of the breaker itself. However, these terms are, again, not exactly the same. Ampere frame is measured in a unit called AF, and it's possible for a 125 ampere frame breaker to have a trip current of anywhere from 60 amps to 125 amps. So they're not exactly the same, but they are used in conjunction with one another to define the breaker's overall breaking capacity. The first one I'd like to talk about are the hold-it case circuit breakers, and these are generally equipped with two methods of overload protection, those being thermal and electromagnetic. The thermal protection consists of contacts that physically deform whenever too much heat is put through the breaker as a result of a high inrush current. These deformed contacts thus break the connection that allows power to flow through. The second type, electromagnetic, works off of a similar principle, but instead the inrush current generates a magnetic field, which actuates a mechanism that disconnects the contacts themselves. The second type of circuit breaker that's worth mentioning are the miniature circuit breakers. They are, as the name suggests, physically smaller than their molded case counterparts, and they usually operate at lower rated currents. It may seem counterintuitive to have a quote-unquote weaker circuit breaker, but these are designed for residential or domestic environments where having a lower trip current may be more desirable. For example, molded case circuit breakers may be ineffective at protecting against the lower current spikes that could very much wreak havoc on your electrical devices. The third type is the earth leakage circuit breaker. These are defined as breakers that have an additional ground point and measure the voltage between the conductors of the breaker itself. Whenever it detects an imbalance or a significant difference, it will automatically trip. They have kind of fallen out of favor in favor of residual current circuit breakers. Residual current circuit breakers, like earth leakage breakers, also can detect electrical issues, but they do so by measuring the current going in and out of the breaker itself. Unlike earth leakage circuit breakers, these breakers don't require a ground point to successfully trip, thus making them effective at protecting against short circuits. There are two major UL certifications that are tied with circuit breakers, those being UL 489 and UL 1077. UL 489 is for standalone circuit protection, meaning that a breaker with this certification can be directly connected to the power supply of the cabinet that it's in and can protect multiple devices downstream. Conversely, UL 1077 is for supplemental protection, meaning that it cannot be connected to the primary power source. It has to be connected downstream of a 489 rated breaker, and it is only allowed to protect one device. It's worth mentioning that you are allowed to use a 489 rated breaker any place that calls for a 1077 rated one, but you cannot do the opposite. If you have a need for a 489 rated breaker, you must use a 489 rated breaker. So now that we've gone over the terminology, the different types, and the certifications for circuit breakers, we have to ask ourselves, which one's the right one for you? The first thing that is important to look at is the environment that you're going to be using these breakers in, as well as the power that's going to be going through them. If you're operating in an industrial environment and you need something for a large cabinet, then you're going to want to consider the ampere frame as well as the rated and trip currents of these breakers. A 400 AF ampere frame would be pretty good for a lot of 240 volt systems, but may not be so great for a domestic environment where the breaker will not trip even when you get short circuits that would definitely fry your home electronics. The other thing that you have to consider is UL certifications. A lot of facilities require that their parts be UL certified, so it's important to look for that on the spec sheet for whatever breaker you might be looking for. That specification is usually listed by the manufacturer. I hope you were able to learn something from this video. If you'd like to see our full range of electrical products, you can find us at misumi.info/electrical.